The objective of this lesson is to partition a set of objects into equal parts and recognize the fractional amount a partition represents. In third grade, students partitioned area models and length models, sharing equally with 2, 3, 4, 6, and 8. Now in fourth grade, students will be introduced to set models with these denominators, as well as 5, 10, 12, and 100 as denominators. Let's begin by using square tiles to help us understand fractions of a set model. A set model is different from an area or length model, as the parts of the whole in the area model are connected. In a set model, the pieces are separate, distinct items. Using 8 tiles, what would 1/8 of the set be? In our example, we could say 1 tile is 1/8 of the set. The 1 yellow tile is what is being considered out of the 8 tiles it takes to make the whole. How about this example? We could describe this fraction as 3/8 of the set is red. There are 3 red tiles being considered out of the total 8 tiles in the whole. Could we name a different fraction if we're considering the blue tiles? We could describe this fraction as 5/8 of the set is blue. The 5 blue tiles being considered out of the total 8 tiles. How could we model 1/5, 1/5, and 3/5 using our tiles? Since the denominator represents the size of the whole, or the total number of tiles, the numerators must represent the number of counters that are different colors. We need 5 total tiles, with 1 tile being one color, another tile being a different color, and 3 tiles all being a different color. Here we have 1/5 that is red, 1/5 that is blue, and 3/5 that are yellow. For example, look at these buttons. What fraction of the set of buttons have 4 holes? It looks like 5 buttons have 4 holes, and there are 10 buttons in the entire set, so the fraction of 4 whole buttons is 5/10. What fraction of the buttons are brown? It looks like 4 buttons are brown, so 4/10 of the buttons are brown. Let's take a look at this carton of eggs. What are some attributes or ways you can describe these eggs? It looks like some are broken and some are not, and some have brown shells and some have green shells. Let's create a model with our tiles to represent the eggs in the carton. How many tiles represent the whole? It looks like the carton holds 12 eggs, so we need 12 tiles. How would you model the fraction of eggs that are green? 4/12 are green, although 2 are broken and 2 are not. We'll use green tiles to represent the 4 green eggs. What fraction of the eggs are broken? It looks like of the total 12 eggs, 5 are broken and 7 are not. So 5/12 of the eggs are broken. What would our model look like to show the fractional amount of brown eggs, green eggs, and broken eggs? Since there are 5 broken eggs, let's have the blue tiles represent the broken eggs, or 5/12 of the eggs. There are 5 whole brown eggs, and we will model them with 5 red tiles for 5/12 of the eggs. Last, we have 2 whole green eggs. Let's model them with 2 green tiles, or 2/12. So here's the set model we have for 5 broken eggs, 5 brown eggs, and 2 green eggs, or 5/12 of the set are broken eggs, 5/12 are brown eggs, and 2/12 are green eggs. Set models can, but do not always have to be the same size or area as the other items in the set, such as the square tiles we have been using. In a set model, the number of items is what is being equally shared or distributed. Your child will continue to explore other examples of set models and identify the fractional amount to describe the parts of the whole. They will continue to deepen their understanding of numerators and denominators and what they represent. The objective for this lesson was to partition a set of objects into equal parts and recognize the fractional amount a particular partition represents. We met this objective by modeling different representations of a whole using tiles and real-world objects.